Hello students, in the previous session you have learned the properties of determinants. Now recall those properties. First property says it is possible to interchange the rows and columns, and if you interchange the rows and columns, the value of the determinant remains the same, delta remains the same. So first property says if the rows and columns are interchanged, the value of the determinant remains the same. And the second property says if the two rows are interchanged, then the sign of the determinant changes. That is the second one, if two rows are, generally we write Ri interchanged to Rj, maybe R2 interchanged to R3, 2 or 3 or Ri, generally we write Ri interchange to Rj, then after interchanging the new determinant delta 1 is equal to minus delta, the sign of the determinant changes. That is the second property. And the third property is very important. If the two rows are identical, that means Ri identical to Rj. If the two rows are identical, then the value of the determinant is 0, delta is equal to 0. If Ci and Cj are identical, the value of the determinant is 0. And the next important property, if there is a common factor in any row or column, it can be taken out. So common factor in any row or column can be taken out of the determinant. Common factor can be taken out. So common factors, if any row or column has common number, then that can be taken out. So fifth important property, that is which all the operations possible. The possible operations are, see, it is possible to apply C1 changes to C1 plus C2 plus C3. It is possible to add up all the columns, elements of all the columns to get the elements of column 1, so that delta value remains the same, determinant value remains the same even if you apply this, or R1 changes to R1 plus R2 plus R3. It is possible to apply such type of operations. Even if you apply these, the value of the determinant delta remains the same. Ri implies Ri plus k times Rj. It's a general way of writing. One row elements, the corresponding elements of Ri are added with Rj elements with multiplied by constant k, or similarly Ci implies Ci plus k times Cj. Yes, it is possible to apply these operations. Now before going to solve the problems, let us see few tips, special tips before solving the problems. So apply 4 rules then to solve the problems based on the properties. Using properties, suppose you have to solve the problem, then always try to apply the operations in such a way that you get the factors of RHS as common term. To apply operations, such type of operations like C1 changes to C1 plus C2 plus C3, or R1 implies R1 plus or minus R2. Okay? Even C1 implies C1 plus or minus C3. So such type of, even R1 implies R1 plus R2 plus R3. These are used to get the factors of RHS. That is the first thing. And if you find any common factor, take it out. Take out the common factor. That is the first rule. And the second rule states that if possible, while taking the common term out, create all ones in any row or column. 1, 1, 1. If try to create ones in any row or column, that means if possible, what is the RHS common factor? When you take out the RHS common factor, try to create 1 in every element of a row or column. And once you get ones in any row or column, subtract the two elements, like if each element of first row or is 1, if 1 1 1 is there in the first row, subtract the two columns. If in any column each element is 1, subtract the two rows. In that way, you have to subtract the two rows or two columns to convert ones in such a way that you will get two zeros. So, any two ones you have to convert into zeros. So, the third point is, once you see all the rows or columns of the elements are ones, if any row or any columns each element is 1, then convert any two of these ones to zeros. So, convert any two to zeros, two ones to zeros. So, if you have two zeros in any row or column, just expand it, get the answer, the RHS part you will get. So, finally, expand it along the row or column containing maximum zeros. So, which row has maximum zeros? Expand the determinant using that row or that column. So, when you expand it, you will get the RHS. So, that is how we can prove the given equation with determinants using the properties. These are the 4 tips we can use to solve the sums. And which are the valid operations? See, unlike in elementary operation where you have learned to find the inverse of a square matrix, there once you apply row operation, you have to follow the same till you get the inverse of a square matrix. Once you apply column operation, you have to apply the same to get the inverse of a square matrix. But when you apply the properties of determinant, it is possible to first apply row operations, then in the next step you can apply even column operation. So, it is possible to apply row operations, and then in the next step or the further steps it is possible to apply column operations or vice versa. So, what are the valid operations? R1 implies R1 plus or minus R2. C1 implies C1 plus or minus C2 plus or minus C3. 3 corresponding elements can be added. R1 interchange to R3, it is possible. 2 arrows means the 2 rows, elements of 2 rows are interchanged. If you interchange the 2 rows or 2 columns, what will happen? Sign of the determinant changes. So, these are the valid operations. Invalid operations, these should not be used, these operations should not be used. R1 changes to, R1 implies R1 plus 2 times C2. So, rows and columns cannot be added or subtracted in one operation. Once you use only row operation, then the next step you can apply the column operation, but it should contain only the columns. When you operate, it should contain only rows or only columns in one operation. So, it is not possible to use R1 implies R1 into R2, product of 2 row elements, not possible, or even it is not possible to divide the elements of 2 rows. C2 is, it does not imply, it is not possible to write C2 implies C2 divided by C1, it is not possible. Even R1 implies R1 into R2, multiplication is also not possible. Only addition or subtraction between the 2 rows are possible. Look at the example. It was asked, this question was asked in the year 2017 for 4 marks. By using the properties of determinants, show that determinant of 1a a square, 1b b square, 1c c square equals a minus b into b minus c into c minus a. The product of 3 terms here. Look at this. First, to solve, our first step is to get the factors of RHS. Factors are a minus b, b minus c or c minus a. So, solution, first consider the LHS, which is 1a a square, 1b b square, 1c c square. Determinant. Now, you have to get the factors. Our first step is to get the factors of RHS. How can you get the factors? Using the operations. Look at this. You have to get a minus b. Here is a, here is b. A minus b we can get by, look at this, R1, first row, second row, third row. We have 3 rows here. To get a minus b as a factor, you need to subtract row 1 element minus row 2 elements, A minus B. We have to apply A minus, we have to get A minus B, that is R1 minus R2. It is possible to apply the first row elements R1 implies R1 minus R2, so that we get A minus B. That is the first factor. Of course, once you get A minus B, the second here the next term also will be you will be getting the same factors, factor A minus B, because A square minus B square. What is A square minus B square? A plus B into A minus B. So, we will have one more factor. And what about the first elements? Here the first elements are 1s. So, 1 minus 1 we get 0. And also in the previously we have seen, if each element of any column is 1, you need to subtract the 2 rows. While subtracting the 2 rows, observe whether we are getting the factors. Okay. So, in the column, first column C1, each element is 1. What can be done now? Subtract the 2 rows. Which way we need to subtract the 2 rows? To get the factors of RHS. In which way we can get the factors of RHS? If it is possible, if we subtract R1 and R2, we will get A minus B. And also the second factor is B minus C. B minus C. So, how can you get B minus C? B here minus C, that means R2 minus R3. So, two operations can be applied simultaneously. So, we will applying R1 implies R1 minus R2, first one. Next, to get B minus C, we can apply R2 implies R2 minus R3. Two operations can be applied simultaneously. So, what is therefore LHS equals? So, R1 minus R2, 1 minus 1, 0. R1 minus R2, this is A minus B. Here, row 1 minus row 2 elements, A square minus B square. Similarly, R2 implies, second row also we are going to change, in which way? R2 minus R3, that is 1 minus 1, 0. Here is B minus C, and the next element B square minus C square. Last R3 we are not altering R3, only R1 and R2 elements are changed. So, R3 remains the same, 1C C square. Now, look at the first row elements 0, A minus B and A square minus B square. We can write A square minus B square as A plus B into A minus B. So, LHS can be written as 0, 0, 1, A minus B, this is A minus B into A plus B, A square minus B square. The second row elements are B minus A, B square minus C square is B minus C into B plus C. Third row elements remains the same, 1C C square. Now, look at this. Here we have first row elements are such that A minus B is common here. 0 into any term is 0. So, A minus B can be taken out from the first row. And what about the second row? Which element is which is a common factor? B minus C is a common factor, B minus C. So, from the second row, B minus C can be taken out. So, LHS equals common factors from first row, A minus B. From the second row, B minus C. Remaining elements, first row 0, A minus B is taken out. So, 1 is left, A minus B is removed. So, A plus B is left. Second row elements, B minus C is taken out. So, 0 remains as it is, B minus C is removed. So, 1 is left, this is B plus C. Third row elements are as it is. Now, look at the determinant. We have in the first column, 2 elements are zeros and the third one is 1. So, when you get 2 elements 0, you have to expand it. So, expanding along the column which has maximum zeros. Here first column has 0, so C1. What do we get? We get LHS equals A minus B into B minus C into, when you expand it along the first column, plus minus plus. So, it is 0 minus 0 plus 1 into, here the third element is 1, first two are zeros, 1 into determinant. Look at this, it is 1 is in the third row and first column. Eliminate third row and first column. What are the 4 elements so formed? These are the 4 elements. Cross multiply, students. So, 1 into B minus 1 into B plus C minus, look at this, 1 into A plus B. So, minus of 1 into A plus B. So, minus sign is there. So, we need to write minus A minus B. Look at this, when you cross multiply, what do we get? B plus C minus A plus B. Minus of A plus B, B plus C minus A minus B. That is why we have written B plus C minus A minus B. Minus of A plus B. So, minus A minus B. Look at this, plus B minus B cancelled. So, what do we have? Which implies we have A minus B into B minus C into here C minus A. Look at this, A minus B into B minus C into C minus A is the RHS right hand side, hence the proof. So, first already we have 1 in the first column, each element is 1. So, subtract the 2 rows, R1 minus R2 and R2 implies R2 minus R3. So, when you subtract the 2 rows, first row elements are, if you observe the first row elements, A minus B is a common factor. Take out A minus B from the first row. In the second row, observe that B minus C is a common factor. Take out B minus C, and since we have in the first column 2 elements are 1, expand it along the first column, so that it is 1 into, delete the row and column where this 1 is in the third row and first column, cross multiply B plus C minus of A plus B. So, minus A minus B. So, we have the factors A minus B into B minus C into C minus A, that is RHS. Look at the second question, which was asked in the year 2017 for 4 marks. Show that the determinant value is equal to x minus y, y minus z, z minus x into xy plus yz plus zx. Now, consider LHS. Solution, consider LHS, which is equal to x square yz, y square zx, z square xy. Look at the RHS, what do we have to get? Which are the factors? X minus y, we have to get x minus y, y minus z, it is possible to get y minus z while applying the operation. Which operation can be applied? X minus y, look at this, here is x and y, x minus y, it is possible to apply like this. This is R1, R2, R3. So, we are subtracting R1 elements and R2 elements to get x minus y. So, the first applying, what you can apply? R1 changes to R1 minus R2. R1 minus R2. R1 implies R1 minus R2. Then, second factor, if you observe, it is y minus z. How can you get y minus z, students? Here y minus z is possible to get when you subtract R2 and R3. So, next one, R2 implies R2 minus R3. Apply 2 operations simultaneously. It is possible to apply 2 operations. We cannot apply 3 operations together, but it is possible to apply 2 operations. So, what is this? Subtract first row and second row elements, x minus y, then x square minus y square, after that yz minus zx, first row elements. Now, the second row implies second row minus third row elements. So, R2 minus R3. So, what are R2 minus R3? Y minus z, that is the second factor. Look at this, y minus z we have to get. Next element, y square minus z square, and then zx minus xy. We have changed only R1 and R2, R3 elements remains the same, z, z square, xy. Now, look at this, what is x square minus y square? X minus y into x plus y. How can you write yz minus zx as? You can observe z is common. So, when you take minus z out, minus x change to plus x, plus y change to minus y, that is what we want, x minus y we want. So, what we do, we take out the common factor minus y. When you change out, okay, sorry, it is minus z. When minus z is removed out, z is common factor here, minus z is removed out, it will be y minus x change to minus of minus x, that is plus x minus y. So, it is from the first row elements are written as x minus y, then this is x minus y into x plus y, isn't it? And here minus z is taken out, remaining elements are x minus y. First row elements. Second row elements are y minus z, y square minus z square is y minus z into y plus z, zx minus xy, x is common, take out minus x, so that it is y minus z. Minus x when you take out, this y is remaining, minus y change to plus y, plus z change to minus z. So, this is LHS. Now, observe that, and in the third row elements remains as it is. Observe in the first row, x minus y is a common factor, x minus y, x minus y, x minus y. So, x minus y is taken out from the first row. What about the second row? Y minus z, y minus z, y minus z. Y minus z is a common factor in the second row. These two elements can be, factors can be taken out. To write LHS equals x minus y is taken out from the first row, y minus z from the second row, remaining elements are 1, here x plus y, then here minus z, 1, y plus z, minus x. Third row elements as it is, z, z square, x y. Right? Now, observe here R1 and R2 elements are such that here the first 1 is in the as a first element. So, 1 here also 1. So, it is possible to subtract these two rows, and the third factor, you know, the third factor is z minus x. Is it possible to get z minus x? Look at this, y plus z minus x minus y. Y cancel, you will get z minus x. Similarly, minus z minus of minus z, minus x minus of minus z. So, minus x plus z or z minus x we will get if you apply R2 minus R1. What you need to apply? Apply R2 changes to R2 minus R1. Okay, so what is LHS? LHS equals x minus y, y minus z into R2 minus R1. So, R2 elements are changing, second row elements, first and third row elements remain the same. So, it is 1 x plus y minus z, and here subtracted 1 minus 1, 0, R2 minus R1, x plus y minus x minus y, R2 minus R1, y plus z minus x minus y, here plus y minus y cancel, y z minus x, z minus x, also minus x minus of minus z, minus x minus of minus z is z minus x. So, it is z minus x. Now, the third row elements z, z square, x y. Look at this. In the second row, you can observe that z minus x is a common factor, z minus x here, z minus x here. So, the third factor, that is z minus x, can be taken out from the second row, x minus y, y minus z, and from the second row z minus x is taken out, remaining elements 1 x plus y minus z, 0, 1, 1, z, z square, xy. Now, it is possible to expand. Look at this, the RHS has 4 factors, x minus y, y minus z, z minus x, xy plus yz plus zx. So, 3 factors we have obtained, we got already 3 factors. Fourth, the last factor we will get by expanding it. We will expand it. You can observe that in the first column we have 1 0. So, expanding along the first column we will get the fourth factor. Expanding along the first column C1 we get x minus y, y minus z, z minus x into, when you expand it along the first column we can write this as plus minus plus. First element is 1 into determinant, delete the first row and first column. The 4 elements are 1 1 z square x y minus 0, second element is 0 here, third one is plus z into, delete the first column and third row. What are the 4 elements? X plus y minus z 1 1. So, now we will expand it, which is x minus y, y minus z, z minus x into 1 into xy minus z square plus z into x plus y minus of x plus y into 1 minus of minus z plus z. So, that x minus y, y minus z, z minus x into, what is it? xy minus z square, multiply this plus x into z, zx plus y into z plus z square. Observe this, the term inside the bracket plus z square minus z square can be cancelled. So, what do we get? X minus y into y minus z into z minus x into xy plus yz plus zx. Is it the RHS factor? Yes, x minus y, y minus z, z minus x into xy plus yz plus zx, which is RHS. Hence the proof. So, first we applied subtracting the 2 rows, get the factors of RHS and then get the maximum zeros. Here we got only 1 0. Expanding along the first column we get all the factors of RHS. Third question, which was asked in the year 2020 March exam for show that determinant of x plus 4 2x 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 x plus 4 2x 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 x plus 4 is equal to 5x plus 4 into 4 minus x the whole square. Look at the factors again, RHS. Factors are 5x plus 4 is the first factor, 4 minus x is the second one. So, using the determinant LHS, x plus 4 2x 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 x plus 4 2x 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 x plus 4. Is it possible to get the first factor 5x plus 4? Look at this carefully. To get 5x plus 4, can we add x plus 4 plus 2x? How much? X plus 4 plus 2x is 3x plus 4. Add 2x to it. How much we will get? 3x plus 2x is 5x plus 4. So, when we add the first column elements, we will change it as adding. In this way also we can add x plus 4 into plus 2x, 3x plus 4, 3x plus 4 plus 2x is 5x plus 4. It is possible to add C1 plus C2 plus C3. First column elements we will change it as C1 changes to C1 plus C2 plus C3. First column elements we are going to change. In which way? First column elements implies C1 plus C2 plus C3. C1 x plus 4 plus 2x plus 2x. We will get 5x plus 4. Similarly, 2x plus 4 plus 2x, again 5x plus 4. Third row also the same, 2x plus x plus 4, we will get 5x plus 4. So, first column elements we are going to change as apply C1 implies C1 plus C2 plus C3. So, LHS equals, so first elements x plus 4 plus 2x, how much? 5x plus 4. So, for x plus 4, 2x plus 2x is 5x plus 4. Then C1 plus C2 plus C3, 2x plus x plus 4 plus 2x, how much? Again we will get 5x plus 4, 5x plus 4. Last one, 2x plus x plus 4, 2x plus x plus 4 is again 5x plus 4. So, here 5x plus 4 we get. Okay. Now, the second and third column elements remains the same. We are changing only first column elements. So, second column elements 2x, x plus 4, 2x. Third column elements 2x, x plus 4. Observe that in the first column 5x plus 4 is a common factor. So, it can be taken out 5x plus 4 into first column elements are 1, 1, 1, 2x, x plus 4, 2x, this is 2x, x plus 4. Okay. Now, what if the first column elements, each element is 1? If each element of first column is 1, then subtract the two rows like R2 minus R1, R1, R2, R3. So, R2 minus R1 and R3 minus R1. It is possible. R2 minus R1, subtract these two, R3 minus R1. So, we will get the factors of RHS and very importantly, we will get 2 zeros. In the first column, we will get 2 zeros. Once you convert in these 3 ones, once you convert it into 2 zeros, then it is possible to expand it along the first column to get the answer. So, apply R2 changes to R2 minus R1 and R3 implies R3 minus R1. So, what do we get? Here R2 minus first row remains the same, we are altering only the second row and third row. So, first row elements are same, here the factor is 5x plus 4, 1, 2x, it remains the same. Second row element 1 minus 1, 0, x plus 4, look at this, R2 minus R1, R2 is x plus 4 minus R1 is 2x. So, x plus 4 minus 2x is how much? 4 minus x, minus 2x plus x is minus x, 4 minus x. So, x plus 4 minus 2x, 4 minus x, 2x minus 2x, 0. Now, R3 minus R1, 1 minus 1, 0, 2x minus 2x, again 0. Then, x plus 4 minus 2x, x plus 4 minus 2x, how much? 4 minus x. So, next element is 4 minus x. Can you see here, first column elements are such that there are 2 zeros. We have converted these two ones to zeros. Once you get 2 zeros in any row or column, expand it along that column or row. So, here in the first column, 2 elements are 0. Now, expand it, expanding along C1, first column. What do we get? We get 5x plus 4 as it is. Now, expand it along the first column. Here plus, minus, plus. At the position signs, 1 into. Look at this, delete the first row and first column. Now what are the 4 elements so formed? 4 minus x, 0, 0, 4 minus x. 4 minus x, 0, 0, 4 minus x. What is this? When you cross multiply, here we have 4 minus x into 4 minus x, 4 minus x the whole square. So therefore, LHS equals 5x plus 4 into 4 minus x into 4 minus x, 4 minus x the whole square. Is it the factor of RHS? 5x plus 4 into 4 minus x the whole square, which is RHS. Hence the proof. So here when you apply C1 implies C1 plus C2 plus C3, we get the first column elements as 5x plus 3, 5x plus 4. So every element is 5x plus 4, take out that 5x plus 4 common term. So first column elements are 1, 1, 1. Subtract the corresponding 2 rows, R2 minus R1, R3 minus R1. So that first row elements are same, second row elements 0, 4 minus x and 0. So 4 minus x is a common factor here and 0, 0, 4 minus x. But you know, first column elements are such that there are 2 zeros. Expand it along the first column, we will get the answer as 5x plus 4 into 4 minus x the whole square, that is RHS.